Modern agriculture is entering a new era, one where technology is advancing at an unprecedented pace. Yet arable land has decreased by 38%, while the global population continues to grow by tens of millions every year. The question is, how can we overcome the limits of land through the power of artificial intelligence and intelligent machines? Today, let's join Agriculture Insight to delve into the high-tech agricultural revolution, where more than 500,000 machines are quietly rewriting the rules of cultivation for humankind. The fixed sprinkler system is redefining how humans call for rain on their fields. Hundreds of sprinkler heads rotate 360 degrees, releasing fine water jets that mimic real rainfall, just about 5 millimeters per hour, allowing moisture to soak deep without eroding the soil. Thanks to a central pressure regulator, water is evenly distributed over areas of up to 30 hectares, saving up to 40% of water compared to traditional furrow irrigation, though installation and maintenance costs are far from cheap. Yet in return, this ability to create artificial rain, even in the dry season, gives farmers control over the weather, keeping the soil soft and crops healthy. Proof that humans can indeed harness nature in the most sustainable way. After irrigation is complete, the next task is to manage excess water. And that's where the Van Dam drainage comes in. At first glance, this machine looks like a mechanical beast, armed with a sharp V-shaped steel blade plunging more than a meter deep into the soil. But instead of destroying, it works with precision, slicing open a narrow trench while simultaneously laying a perforated pipe beneath the surface. In a single smooth motion, it lays, covers, and compacts, leaving the field surface almost untouched. When the last wheel passes by, the only trace left is a faint line on the soil. Beneath it, however, lies an artificial network of underground channels where excess water quietly flows back to the main ditch, keeping the soil aerated, roots dry, and moisture balanced all year round. Without open digging or disturbing the topsoil, this method saves both time and labor while preserving the entire vegetation layer above. A subtle yet powerful way to let the earth breathe naturally again. Across open fields, the sight of farmers wrapped head to toe in protective gear, walking through clouds of pesticide mist, is slowly disappearing. Taking their place is the R150 spraying robot, faster, more precise, and completely safe. Guided by RTK positioning with an accuracy of just a few centimeters, the R150 moves automatically along crop rows, avoids obstacles, and memorizes the entire field map. Its electronic nozzles and smart sensors ensure every spray is applied at the right spot, in the right dose. No overlaps, no misses, cutting chemical use by up to 40%, and water consumption by as much as 90%, while maintaining the same pest control efficiency. The robot works effectively on rice paddies, cornfields, vegetable plots, and low canopy orchards, while taller and denser crops are handled by spraying drones. Powered by an emission-free electric motor, the R150 marks a new step toward a greener, smarter, and truly sustainable era of agriculture. In a world where every drop of water and every minute of labor matters, laser weeding robots are redefining what it means to pull weeds. Instead of using herbicides containing glyphosate, a major culprit behind soil and water pollution, the LaserWeeder targets weeds with 30 high-powered CO2 lasers, striking with millimeter-level precision. Powered by AI that processes over 5 million images per hour and supported by a powerful LED lighting system, it can operate continuously, day and night. Each laser blast doesn't just burn weeds on the surface, it also destroys their seeds in the soil, preventing regrowth entirely, something chemical herbicides could never achieve. Within just 1 to 3 years, farmers can recover their investment, and more importantly, take a meaningful step towards smarter, cleaner, and risk-free agriculture. Liquid fertilization is one of the most crucial steps in closing the nutrient cycle, returning organic matter to nourish the very soil that gave it life. The Fuchs slurry spreader turns what once was a labor-intensive task into a process of millimeter-level precision. Its 18,000-liter tank is constantly stirred to keep the mixture uniform, while a high-pressure pump system pushes the slurry through 15-meter-wide applicators placed close to the ground. This allows nutrients to be absorbed directly by the roots, reducing nitrogen loss by up to 70% compared to conventional spraying methods. Interestingly, if the stirring stops for even a few minutes, solids begin to settle and clog the entire system. A small detail that reminds us, even in modern agriculture, balance and continuous motion remain the keys to keeping the soil alive, the crops green, and the harvest sustainable. In Costa Rica, one of the world's largest banana exporting hubs, transportation is considered the lifeline of the entire supply chain. Instead of manual carrying, farms rely on overhead cable systems that stretch up to 20 kilometers around the plantations, continuously moving freshly harvested bananas. After harvesting, workers carefully wrap each banana bunch. Soft plastic pads are placed between the hands of fruit, not only to prevent bruising as they rub against each other, but also to maintain airflow, ensuring even ripening. A small blue plastic sleeve tied around the stem may look simple, yet it serves 3 vital purposes: keeping insects away, reducing friction with the cable, and preventing sap from dripping and staining the fruit. Once prepared, the 40 to 50 kilogram bunches are hung onto the cable line. Suspended beneath a network of steel rails, hundreds of banana clusters glide smoothly along the cables, rolling toward the packing station. Thanks to this gravity-powered transport, the fruit never touches the ground, minimizing damage and preserving freshness, ready for the next stage of processing and their long journey across the ocean to tables around the world. And right here, inside the greenhouse, a compact yet highly advanced automated transport system is at work, moving seedling trays with remarkable precision. Suspended on overhead rails above head height, the robot glides smoothly between hundreds of vertical growing layers, receiving commands from a central control unit to grip, lift, move, and stack each tray with an accuracy of less than 2 millimeters. Each day, a single robot can handle more than 5,000 planting trays, replacing at least 10 human workers, and it never needs a break. Equipped with sensors and optical cameras, it automatically detects the weight, moisture, and position of each tray to adjust its grip strength, preventing damage to fragile young plants. Operating continuously in a closed environment, the trays are moved cleanly, quickly, and flawlessly, creating a seamless, self-sustaining cycle where humans simply oversee the process and robots take care of the heavy, repetitive, and delicate work. Inside the same greenhouse, Sweeper is more than just a robotic arm. It's a symbol of how artificial intelligence and mechanical engineering are reshaping European agriculture. Its main frame is built from ultra-light aluminum alloy, with electronic joints that allow the arm to move flexibly within the narrow rows of crops. At the front, a high-resolution 3D camera cluster surrounded by spectrum-adjustable LED lights enables the robot to see the exact shape and depth of each pepper, even under shifting light conditions. Beneath it, the cutting mechanism works like a metallic hand. 4 soft silicone fingers position the fruit, while a motorized steel blade snips the stem in a single precise motion. In greenhouse trials, sweepers successfully harvested around 61% of the peppers, averaging 24 seconds per fruit. Though it can't yet match the speed or dexterity of human hands, it represents a groundbreaking step toward a new generation of robots that can adapt and learn on their own. Out on the field just past the mowing season, the hay baler comes to life, wrapping up the harvest with power and astonishing precision. At the front, a pickup system swiftly gathers dry grass into the rotary compression chamber, where massive steel rollers work like a beating heart, pressing and spinning to form perfect round bales over 1.2 meters wide, weighing up to 800 kilograms. Once the ideal density is reached, weave automation automatically wraps the bale with a double twist net, tight enough to hold every strand, yet airy enough to prevent mold, before gate automation opens smoothly, releasing a flawless bale that gently rolls to the ground like a piece of mechanical craftsmanship. All of it happens in less than 45 seconds per bale. No shouting, no straining hands, only the steady rhythm of technology, where farm labor transforms into mechanical artistry. Unlike green asparagus, white asparagus, often called Europe's white gold, grows entirely in darkness, buried deep beneath the soil to preserve its pale color and tender sweetness. That very delicacy once made harvesting nearly impossible. Just a few millimeters off could snap a stalk worth tens of euros. That's why robotic harvesters have become essential to the white asparagus season. Starting in April, when the shoots barely break 2 centimeters above the surface, optical sensors and AI cameras sweep across the field, pinpointing the exact position and depth of each spear. In an instant, a hydraulic arm lowers, digs a narrow trench, grips the stalk, and lifts it gently through a vacuum tube. Inside, high-speed rotating brushes remove soil without scratching the smooth wax-like skin. What makes this technology remarkable is that it doesn't just replace labor. It redefines the human touch with the earth through computer vision and flawless precision. Each robot can cut up to 80% of labor costs, all while preserving the pristine perfection of this Michelin-grade delicacy. Gliding smoothly between the hazelnut rows, this intelligent harvester unleashes dozens of high-speed rotating brushes, creating powerful air currents that feed into a giant suction hose, swallowing up a carpet of nuts, dry leaves, and loose soil from the ground. Unlike almonds or walnuts that require vigorous shaking from tree shakers, ripe hazelnuts naturally fall in unison during a brief 2 to 3 week autumn window. Yet, that fleeting moment is also their greatest vulnerability. Just one untimely rainstorm can turn a golden harvest into a soggy, moldy disaster. The arrival of this harvesting machine has completely solved the race against time, becoming a true savior for farmers in Turkey, Italy, and the United States, helping them secure millions of tons of hazelnuts each year. Once the entire mixture is drawn into the machine's body, massive fans and rotating drums generate a man-made whirlwind. Dry leaves, dust, and light debris are blown away, while the heavy hazelnuts drop neatly into the storage bin behind. One pass of this machine replaces hundreds of manual workers, turning grueling labor into a compact, spectacular, and powerful display of mechanical precision. Combine harvesters, the towering giants that embody the speed and sheer power of modern agriculture, stand behind tens of millions of tons of barley harvested across Europe each year. Over 4 meters tall and more than 10 meters long, these machines wield razor-sharp blades and massive rotating reels that sweep through the golden fields, slicing through rows of barley in just a few swift passes. Inside, a compact yet relentless processing line comes to life. Powerful threshing drums spin at high speed to separate the grains from the heads. Vibrating sieves shake continuously to remove straw and impurities, while strong fans blow away husks and dust. After this perfectly synchronized motion, only the finest barley grains are conveyed into the storage tank, while the leftover straw is gently spread across the field, completing a flawless cycle in every turn of steel. With these colossal steel reapers, bringing in millions of tons of barley within just a few short weeks becomes effortless. Even when sudden fires break out under dry, scorching weather, they can still race against nature, harvesting, rescuing, and preserving the golden season before the flames can spread. What would happen if the irrigation canals, the lifelines of agriculture, were clogged with mud, waste, and weeds? In the worst-case scenario, an entire season's harvest could be lost. Water stops flowing, the fields crack and dry out, and crops wither under the sun. That's why specialized canal dredging machines were created, like steel arms ensuring that the agricultural bloodstream remains open and flowing. Among hundreds of designs today, the most common and efficient are hydraulic arm dredging machines mounted on tractors. With a flexible boom that can swivel 180 degrees, the rotating drum at the end scoops, stirs, and lifts mud from the canal bed while trimming weeds along the banks. Some advanced models from Hemos, Netherlands, and Greentech, Denmark, even feature pressure sensors and automatic leveling systems, allowing precise operation in narrow trenches. In countries like the Netherlands and Germany, large-scale versions equipped with giant rake buckets attached to hydraulic cranes are also popular. Dozens of curved steel tines work like a massive comb, scraping away sludge and debris without damaging the canal walls, keeping the water clean and free-flowing. Thanks to mechanical power, just a few hours of work by one of these machines can replace an entire day's labor by dozens of workers, restoring clogged waterways and helping the fields breathe again with the rhythm of the growing season. In fruit orchards growing mangoes, avocados, or longans across Europe and Latin America, Greentech circular disc pruners are considered an ideal solution for small and medium-scale farms. Equipped with multiple high-speed rotating steel saw blades, these systems precisely trim each canopy layer, allowing light and air to circulate freely between branches. The result is well-balanced tree growth, evenly ripened fruit, and a significant reduction in pests, something that manual pruning can hardly achieve. But for large-scale plantations in the United States, Brazil, or Australia, where each orchard row stretches for hundreds of meters, farmers prefer horizontal fan blade trimmers. Their wide cutting structure and blade speeds exceeding 2,000 rotations per minute enable the machine to trim both sides and the top of the canopy in a single pass. Compared to the disc-type models, which focus on precision, the fan blade trimmers excel in speed, productivity, and wide area coverage, making them the perfect fit for intensive farming regions where every minute of operation holds high economic value. Soaring over endless green cornfields across Iowa, Nebraska, and Kansas, the air tractor and thrush aircraft, the steel wings of American agriculture, have lifted the entire industry to new heights, where the sky itself becomes an extension of the farmer's hand. Flying just 3 to 5 meters above the ground, these planes precisely spray GPS-guided ribbons of pesticides and fertilizers, covering more than 16 million hectares of corn each year, with near-perfect uniformity. Inside the cockpit, a high-pressure spraying system works in harmony with sensors measuring wind, humidity, and flight speed, automatically adjusting the flow rate in real time to ensure every drop lands exactly where it's needed. No more, no less. With performance tens of times greater than ground-based spraying methods, these reapers of the sky have become a symbol of peak mechanization in 21st century agriculture. Yet alongside their extraordinary efficiency come debates that never fade. Drifting chemicals carried by the wind, high operational costs, risks to pilots, and the long-term environmental impact that continues to challenge even the most advanced form of aerial farming. Before the arrival of liquid manure spreaders like GEA, Noon, or Husky, applying organic fertilizer used to be one of the toughest and most dreaded tasks for farmers. Today, technology has completely transformed that picture. From manure pits more than 10 meters deep beneath livestock farms, high-capacity pumps draw the liquid fertilizer through high-pressure pipelines and send it straight into the machine's massive storage tank, with a capacity of up to 50,000 liters. In traditional centrifugal spreading systems, a hydraulic pump drives a fan rotating at 2,000 revolutions per minute, creating a powerful spray that covers up to 25 meters in width, ideal for dry fields and flat terrain. This mechanism is simple and fast, but still suffers from significant nutrient loss due to evaporation. Meanwhile, modern subsurface spreading systems use an 18-meter distribution arm that injects the fertilizer directly into the soil, delivering nutrients straight to the root zone. This innovation virtually eliminates nutrient loss, reduces odor, and maximizes absorption efficiency, a breakthrough now widely adopted across Europe, North America, and New Zealand. In just a few hours, one machine can cover more than 50 hectares of land, saving up to 90% of the time compared to traditional methods. With 4 massive steel claws capable of digging more than 2 meters deep and gripping root balls weighing several tons, these large-scale tree spades have turned the once daunting task of uprooting and replanting trees into a remarkably simple operation, achieving survival rates of over 98%. When the hydraulic steel blades simultaneously pierce the ground, they carve out a perfect conical root ball, preserving the soil's microstructure and the tree's natural moisture balance. Moments later, the machine gently lifts the entire tree and its root ball, rotates it to align with its original sun orientation, and lowers it into a newly prepared planting hole. Thanks to a synchronized system of pressure sensors, precise hydraulics, and a high-strength steel frame, the entire process, uprooting, transporting, and replanting, takes only a few minutes. This replaces the work of dozens of manual laborers and crude equipment, making the tree spade a true savior for urban forestry projects, parks, and the relocation of old, mature trees. Amid vast vineyards in California, France, and Italy, especially in spring and early summer when mold and mealybugs spread rapidly, airblast sprayers glide tirelessly between the rows. Equipped with 1,000 to 3,000 liter tanks and powerful rear fans, they turn pesticide solutions into a fine mist that penetrates deep between the leaves, coating both sides of the grape canopy, something manual spraying can hardly achieve. In modern models like the Twister S6, sensors and GPS automatically adjust pressure, airflow, and spray rate based on canopy density, reducing chemical loss by up to 40% and saving thousands of liters of solution each season. In just a few hours, a single air blast sprayer can cover dozens of hectares, becoming the indispensable steel assistant of modern vineyards. Automated weeding machines powered by cameras and artificial intelligence are transforming the way Americans care for fields of lettuce, spinach, and kale. Equipped with high-resolution cameras that constantly scan the ground, the AI can distinguish each crop and weed with centimeter-level precision. Once a weed is detected, hydraulic blades swiftly extend and cut around the base of the crop without harming its delicate leaves. All operations are synchronized through GPS and speed sensors, allowing the machine to adjust automatically to terrain and plant density. In just a few hours, dozens of hectares can be completely weed-free without any human labor. However, with a price tag of $350,000 to $500,000, these robot farmers remain a luxury dream for many small farms. In May, across the green tea hills of Shizuoka, Japan's tea capital, machines begin stretching black nets over rows of young tea plants. During 10 to 30 days of this shading period, sunlight is partially blocked, allowing the leaves to retain L-theanine and chlorophyll, the secret behind the jade green color and signature umami flavor of premium sencha, kabusecha, and matcha. When the shading ends, Valiant or Maruyama harvesters glide gently along the rows, trimming a layer of tender shoots just a few millimeters thick. Built-in fans and conveyors collect the leaves into mesh bags, while GPS sensors automatically adjust cutting height and speed to capture only the finest parts. In just a few days, technology and tradition unite to create Shizuoka's perfectly timed tea season, where every leaf preserves the pure umami essence of the earth and sky. In Germany, the United States, and the Czech Republic, the world's great beer workshops, the once labor-intensive harvest, which used to require hundreds of workers climbing trellises to cut vines by hand, has now been transformed by massive hop harvesting machines operating with near-perfect precision. From a cabin level with the canopy, the operator grips the hop vine, cuts it from the trellis, and feeds it directly onto a conveyor belt. Inside, hundreds of rotating metal fingers swiftly strip the cones from leaves and stems, blowing the waste aside while the heavy, oil-rich hop cones drop neatly into collection bins. Each machine can process over 1 hectare of hops per hour, the equivalent of about 150 human workers. In an industry producing more than 190 billion liters of beer annually and consuming hundreds of thousands of tons of hops, these harvesters are more than just machines. They are the backbone of the beer world, where steel and engineering keep the flavor of humanity endlessly flowing. Our first stop takes us to California, the largest vegetable basket in the United States, where vast fields of red cabbage are entering peak season. These gigantic harvesters are the driving force behind hundreds of thousands of tons of cabbage each year. With a specially designed clamping head, the machines gently lift each cabbage from the soil and place it directly onto a conveyor belt. There, rollers and vibrating screens remove excess soil and old leaves, leaving only firm, uniform heads. Immediately afterward, the cabbages are transferred to the main conveyor and dropped straight into large wooden crates or accompanying trucks, ready to leave the field. With a capacity of 5 to 7 tons per hour, many times greater than manual labor, These steel giants help farmers save time, cut costs, and ensure that massive volumes of red cabbage reach the market in time during the short harvest season. In September, the vast potato fields of Idaho, the potato capital of the United States, turn into battlefields for giant harvesting machines. As these steel beasts move into the fields, their digging blades and steel lifting wheels gently cut through the soil ridges, raising entire potato plants without bruising the tubers. Next, a system of vibrating conveyors and rollers continuously sift and separate soil, stones, and foliage, leaving only clean, intact potatoes. The selected tubers are then transferred onto the main conveyor and dropped directly into accompanying trucks, ready to be transported to cold storage. To own one of the latest potato harvesters, farmers must invest between $250,000 and $500,000. Hefty price, but one that pays off with superior productivity of 15 to 30 tons per hour, reduced labor costs, and consistent harvest quality on an industrial scale. But before millions of tons of potatoes can be harvested, the true groundbreaker of modern agriculture, the heavy disc harrow, plays its indispensable role in preparing the soil. When pulled by a high-horsepower tractor, dozens of massive steel discs arranged in offset rows begin to spin, tilling the entire surface of the field. With each rotation, they not only chop up straw and weeds, but also break through the hardened soil beneath, mixing crop residues into the earth to enhance its natural fertility. Behind them, a heavy roller smooths the surface, transforming dry, compacted ground into a loose, level, and nutrient-rich layer, perfect for planting or for the next stage of mechanized farming. With working widths spanning dozens of meters and a processing speed many times faster than traditional methods, the heavy disc harrow is seen as the silent pathfinder, whose role ultimately determines the success of an entire harvest. Across the vast peat fields of Finland and northern Europe during the damp rainy season, the screw trencher appears as agriculture's silent drainage worker. Its massive auger drills deep into the soil, flinging wet earth to both sides and carving straight trenches in a single pass, keeping fields dry, loose, and protecting root crops prone to rot, such as potatoes, carrots, and sugar beets. With the ability to cut several kilometers of trenches each day, this machine has transformed waterlogged land into fertile fields, paving the way for bountiful harvests. The modern turf rolling machine is the true craftsman behind the lush green rolls of grass used for football fields, golf courses, and urban landscapes. Its sharp cutting blades slice through the turf along with a thin layer of soil, while a conveyor immediately feeds it into the rolling unit, where rotating shafts neatly wind it into tight, carpet-like rolls. In the past, this task required dozens of workers, but today a single machine can handle several hectares in a short time, making it an indispensable tool in the industrial turf industry across the United States, Europe, and Australia. Back in the vineyards stretching across Bordeaux, Tuscany, and California's Napa Valley, modern grape harvesters are setting their signature rhythm into motion. Instead of dozens of workers stooping to cut each cluster by hand, these towering machines envelop entire rows of vines and activate their flexible shaking rods. Each precise vibration causes ripe grape bunches to drop all at once, while the branches remain intact, minimizing damage. Immediately afterward, gentle conveyors catch the fallen grapes and carry them through powerful fans that remove excess leaves and dust, leaving only plump, juicy fruit. With just a single pass, Entire rows spanning tens of meters are neatly harvested, many times faster than manual labor. Finally, the grapes are emptied into specialized trucks, ready to head straight to the winery for their journey toward becoming fine wines enjoyed on tables around the world. The Oxbow citrus harvester is currently the leading choice on the market, especially in Florida's high-density orange groves, which supply over 70% of the nation's oranges. Unlike older models that relied on trunk-shaking mechanisms, the Oxbow operates with a modern drive-through system. The machine moves between two rows of trees, where rotating spiral shafts on both sides brush vigorously against the canopy, causing ripe oranges to fall en masse. Immediately, collection pans and conveyors beneath catch all the fruit, then channel them through strong airflows to remove leaves and twigs. The selected oranges are transferred directly into large onboard bins or unloaded straight into accompanying trucks. This season, the lush spinach fields are entering peak harvest. While it might seem that such delicate leafy greens could only be hand-picked to avoid damage, specialized machines have proven otherwise. Before you is a massive spinach harvester gliding smoothly across the rows. Its rotary cutting blades operate just a few centimeters above the ground, swiftly trimming entire mats of spinach in an instant. Immediately afterward, a suction system and rear holding bin collect the tender leaves, arranging them into neat layers before unloading directly into trucks running alongside the field. In some advanced models, mesh bins equipped with light compression mechanisms press the spinach into compact square blocks, saving transport space while helping the leaves retain their crisp freshness throughout the journey to processing plants or cold storage. Despite variations in design, all share the same advantage: reducing harvest time to just a few hours for fields spanning dozens of hectares, dramatically cutting labor costs, and most importantly, preserving the tender, clean spinach leaves that are ready to supply the global market. On the brittle, sun-baked soils of California, giant onion harvesters roar into action, turning parched golden fields into open-air production lines. At first glance, these machines resemble potato harvesters, with blades that lift the bulbs from the earth. But unlike potatoes, the onions are neatly laid out in long rows behind the machine, left to cure directly in the field for 7 to 14 days. Once their papery skins have dried to the ideal 80 to 90%, specialized trucks equipped with conveyors sweep in to gather them, transporting the crop to colossal storage facilities. These state-of-the-art warehouses, fitted with advanced ventilation and humidity controls, can hold tens of thousands of tons from a single harvest. Thanks to these steel warriors, a once backbreaking task has been transformed into a breathtaking display of mechanical precision, delivering onions straight from the soil to the global supply chain. Lettuce harvesters are engineered to handle massive volumes while preserving the crisp freshness of every head. At the front, a row of cutting blades sweeps across the field, slicing each plant just a few centimeters above the ground with pinpoint precision. Immediately, soft rubber conveyors lift the lettuce onto the line, where fans and rollers strip away soil, grit, and outer leaves. The cleaned heads then move to an onboard sorting station, where workers quickly inspect, grade, and place them directly into crates, ensuring that the lettuce travels from field to box in a single seamless motion. The latest generation of almond harvesters introduces a striking U-shaped design, large enough to encircle an entire tree in a single pass. Perfectly suited for California's neatly planted orchards with uniform canopies, this machine glides down the rows, shaking the tree while its internal catching frames collect the falling almonds. From there, conveyors move the nuts either into tidy windrows or directly into onboard storage. The result: harvests completed many times faster than hand-picking, with minimal nut loss. Another widely used method across California relies on powerful tree shakers. These machines clamp tightly around the trunk and deliver intense vibrations, triggering a dramatic rainfall of almonds within seconds. Once the ground is carpeted with nuts, sweepers gather them into rows, and pickup machines follow to clean and separate debris. Some of the latest models even integrate hoppers or mobile conveyors, allowing them to shake and collect at the same time, streamlining the process and maximizing efficiency. Every year, more than 40 million tons of carrots are harvested worldwide to meet the massive demand for this nutrient-rich crop. Instead of relying on labor-intensive hand-pulling, modern carrot harvesters can uproot, clean, and collect carrots in a single pass. The process begins with non-slip rubber clamps that grip the leafy tops and pull the carrots smoothly from the soil. Immediately, a set of high-speed circular blades slices off the greens, sending the tops onto a side conveyor to be dropped back into the field. Meanwhile, the carrots travel across spiked cleaning belts that shake off soil and fine roots. Finally, a long main conveyor, stretching up to 5 to 8 meters, delivers the cleaned carrots directly into the bins of a parallel trailer, ensuring a gentle drop that minimizes breakage. With this system, a single machine can harvest 60 to 80 tons of carrots per hour, 20 to 30 times faster than manual labor, while keeping crop damage to an absolute minimum. This colossal fleet is the driving force behind nearly 300 million tons of sugar beets harvested each year. Across vast fields spanning thousands of hectares in Europe and the US, giants like Ropa, Homer, and Vervaet, towering 4 meters high and stretching over 15 meters long, work like mobile factories right in the middle of the farmland. As the machine advances, high-speed front-mounted knives shear off the leafy tops. Immediately after, disc wheels or lifting rollers dive into the soil, gently raising the bulky roots from the heavy earth. The beets then ride up vibrating conveyors and rotating rollers that shake off soil, stones, and excess roots. From there, the cleaned beets flow through multiple conveyor stages before filling an onboard tank with a massive capacity of 30 to 40 tons. Thanks to this system, a single harvester can clear more than a hectare in under 30 minutes, hundreds of tons in a single day, far beyond human labor, making these machines the backbone of the modern sugar industry. Once full, the harvester's long unloading conveyor transfers the crop into waiting trucks or onto massive field-side piles, ready for transport to the sugar mills. With a wingspan of up to 40 meters and the ability to spray thousands of fine, mist-like water jets, the boom irrigation system before you is a trusted helper for Dutch farmers caring for vast tulip fields stretching over thousands of hectares. Its operation is impressively clever. The boom is extended to the area that needs watering, directly connected to water channels and a pressurized pumping system. Hundreds of tiny nozzles along the steel arms release water in unison, creating an artificial rain that blankets every row of flowers. Thanks to its even spray and ultra-fine droplets, this system can save up to 40% of water compared to traditional methods, helping the tulips grow uniformly while keeping their vibrant colors intact. But to keep the tulips not just beautiful, but healthy, farmers rely on another shield, a self-propelled spraying machine with a tank holding up to 6,000 liters. The wingspan is still impressive, stretching wide across the field. But this time, its mission has changed. Hundreds of nozzles release a fine mist, covering every petal and leaf, forming an invisible barrier against pests and mold. In just 1 hour, the machine can treat 15 to 20 hectares, dozens of times more efficient than manual labor, saving chemicals, reducing pollution, and ensuring every tulip reaches absolute perfection. But no matter how stunning the flowers are, they still need to be removed, because the real value Dutch farmers aim for lies underground, the tulip bulbs. Only by removing the blooms can the nutrients be fully directed to grow big, strong bulbs that meet export standards. The tulip cutting machine, or tulip topper, is designed compactly to fit neatly between rows for easy movement. At the front, specially shaped rotating blades cut only the flower heads, leaving stems and leaves intact to continue photosynthesis and nourish the bulbs. Thanks to this precision, hundreds of hectares of flowers are processed quickly and accurately, laying the foundation for the multi-billion-dollar tulip bulb industry each year. Unlike tulips, which are harvested with just a gentle cut at the bloom, lavender enters its season with massive machines, a clear sign of its importance, as it supplies up to 70% of the raw material for the global perfume industry. The cutter-gatherer works with rotating disc blades that slice close to the rows, then clamp and lift the purple stems onto a conveyor, compressing them into large bundles neatly dropped into a storage compartment. This method preserves the whole stems, producing pure essential oils, perfect for high-end perfumes or handcrafted dried bouquets. The trade-off, however, is a slower pace and the need for more handling afterward. On the other hand, modified Class Jaguar harvesters are built for speed. Their cutting blades and chain system continuously chop, shred, and suction the lavender, blasting the fragments directly into a truck driving alongside. This approach can clear hundreds of hectares within just a few days, saving on labor and costs, though the oil quality is slightly lower and usually destined for large-scale industrial use. Whichever technology is chosen, the goal remains the same: to transform the endless purple fields of Provence into the fragrant heart that sustains the world's perfume industry. The moldboard plow, the true season opener of every harvest, stands out with its ability to turn the very skin of the earth in a single pass, awakening the life hidden deep underground. Heavy-duty tractors boasting pulling power of 250 to 400 horsepower tow behind them a set of perfectly curved plow blades. Crafted from ultra-durable steel with smooth flowing surfaces, these exceptional blades can slice, lift, and flip soil 180 degrees in just one motion. Thanks to their precise angles and polished finish, the soil doesn't shatter chaotically, but instead folds neatly into even strips, burying weeds, pathogens, and crop residues while bringing the fertile lower layers up to the surface. A modern moldboard plow on today's market ranges from $15,000 to $40,000, depending on its size and number of blades, excluding the tractor itself. It's a major investment, but one that pays off with unmatched efficiency across large-scale farmlands. On the vast fields of Idaho, the potato capital of the United States, Grimm potato planters have replaced manual labor with a 5-step process completed in a single pass, cutting down planting time, saving up to 70% in costs, and bringing agriculture to true industrial standards. At the front, tillers and furrow openers break up the soil, carving out perfectly straight rows. As the earth is turned, Flocks of birds swoop down, snatching up the worms and insects that appear, turning the entire field into a lively feast where nature and machinery move in harmony. Immediately after, ridge formers shape the soil into uniform beds with precise dimensions. Behind them, massive seed hoppers feed tons of seed potatoes onto conveyors, dropping them through chutes at exactly the right spacing and depth. Just seconds later, covering discs close the soil to lock in moisture, while integrated fertilizing and spraying systems add nutrients and protect the crop from pests right from the start. Thanks to these steel giants, planting thousands of hectares, once a job that took weeks, can now be done in just a few days. Though the initial investment is significant, the efficiency they deliver makes them a golden asset for any industrial-scale farm.